All right, honors calcers, welcome back. Friday, let's start with a prayer. Let's do Latin prayer on Friday. How about that? Ed Puzzle, Latin prayers. In the name, in nomine Patris et Filii, Spiritus Sancti. Amen. Ave Maria, gratia plena, Dominus tecum, benedicta tu in mulieribus, et benedictus fructus ventris tui, Iesus. Sancta Maria, Mater Dei, ora pro nobis peccatoribus, nunc et in hora mortis nostrae. Amen. Sancte Joseph, ora pro nobis, in nomine Patris et Filii et Spiritus Sancti. Amen. Okay, so welcome back. Had a little Latin Hail Mary there. Okay, it's great to pray in Latin. Latin's the language of the Catholic Church. So, we need to use it a little bit more than we do now. So I'm going to start just with a review, and we're just going to do some more power rule, but just some problems where you have to simplify first. But again, the power rule is the same. Remember, you bring the exponent down, subtract 1 from the exponent, and that's your answer. Now, again, as we did yesterday, you have to do a lot of other ancillary things before you can take the power rule, okay? And I would just say, just remember, let's get the final answer as a radical, okay? But when we're taking the power rule, we want it to be, okay, we want our expression to be in exponential form. So again, right, if we look at this expression, I'm going to rewrite this expression. So first I'm going to say find y prime. Okay, y prime means find the derivative. But we're going to rewrite y, so that's x to the 7 halves plus 3x to the 1 half. Okay, so y prime is 7 halves x to the 5 halves plus 3 halves x to the negative 1 half. Okay? So this first one, 7 halves. This becomes the square root of x to the 5th. Remember, the denominator of the denominator of the exponent goes outside, the numerator goes inside. Now this next one here, we have 3 halves. So since I have x to the negative 1 half, I got to put that in the denominator. Okay, and last step, so you can put this in the numerator or you can leave it like I left it. Doesn't make any difference. And we get 3 over 2 squared x. Okay. Very good. Okay. And that's our derivative, okay? Now, if I said find f prime of 1, right, you plug in 1 for x, you get 7 halves plus 3 halves, which is 10 halves or 5, okay? So just a heads up that, that's still in play. All right, so again, what we're trying to do today is we're just going to simplify expressions first, right, if we can, and then take the derivative using the power rule. So, for example, this first one, if I want to find y prime, I'm going to rewrite y, okay? Remember, number 1, we're going to use distributive property, okay, to multiply that x squared by everything. Remember, this exponent here is a 1. And when you multiply 2 powers with the same base, you add the exponents, right? We did that as a review in September. So now we get x to the 5th plus 5x to the 4th plus 2x cubed. And now since this is written as a polynomial, okay, with no multiplication that has to be done, I'll find y prime. That's 5x to the 4th plus 20x to the 3rd plus 6x squared. Okay? All right. So again, bring the exponent down and subtract 1 from the exponent. Okay? All right. Now this next one, we have y equals 2x squared minus 3x plus 1 all over x. So instead of distributing, we're going to have to divide x, okay, into all of these terms, okay? So the first one, 2x minus 3, those are nice, plus 1 over x, right? So if I've divided each term in the numerator by x, okay, I'm going to just rewrite one more time, okay, because 1 over x is x to the negative 1. And now I can take the derivative. Y prime equals 2. The derivative of any constant is 0. And it's minus 1x to the negative 2. Okay? Bring down the negative 1, subtract 1 from the exponent. So we get y prime equals 2 minus 1 over x squared. Okay? Okay, next one. Again, division, you divide the denominator by each term in the numerator. So we get y equals 5x squared plus 3 over x. This is the same as y equals 5x squared plus 3x to the negative 1. Take the derivative, we get 10x minus 3x to the negative 2. So our final answer is 10x minus 3 over x squared. Okay. Boom. All right, next one, number 4. So again, we have a distribution. Okay. Now again, square root of x is known as x to the 1/2. Okay. So maybe you want to write that out first. Okay. And again, when you multiply same bases, we add the exponents. So we're going to get x to the 5/2 plus, again, 3x to the 3/2 plus x to the 1/2. Okay. Then we're going to take derivatives again. We get 5/2 x to the 3/2 plus 9/2 x to the 1/2 plus 1/2 x to the negative 1/2. Clean this up. My apologies. This is y prime right there. So we have 5/2. It's the square root of x cubed plus 9/2 square root of x plus 1/2. And on the bottom, x to the 1/2. And then again, if you want, you can write all the, you can put the, you can put those in the numerator if you want. You're not required to. And then this turns into square root of x. All right, so we're always trying to go backwards, right? And our answer should end in a radical, with the radicals in it, okay? But mostly you'll see to the 1/2 power, right? You'll see the denominator have a 2. Okay, that means it's a square root. So really, it shouldn't be too crazy, but you do be on the lookout for the other ones. Okay, last one. We're going to rewrite again. So let's start with 2x cubed minus 5 over x to the 1/2. Okay, so again, we're going to divide each term in the numerator by x to the 1/2. So we get y equals 2x to the 5/2, right? Because when I divide two powers, I'm going to subtract the exponents, right? So 3 minus 1/2, that's 6/2 minus 1/2 equals 5/2. Then we get 5 over x to the 1/2. Rewrite one more time, 2x to the 5/2 minus 5x to the negative 1/2. So we get, I'm going to write this out this time, 5/2 times 2, x to the 3/2 plus 1/2 times 5, right? I brought the negative 1/2 down, x to the negative 3/2. So now I've got 5x to the 3/2 plus 5/2 over x to the 3/2. And I get y equals 5 square root of x cubed plus 5 over 2 square root of x cubed. Okay, so it all goes back to the rules also that we talked about yesterday with rational exponents, okay? But you've got to be, you've got to be sure of how to convert between them, okay? So if you need more practice on that, I can post a Delta Math, that's not graded, but which will be practice for you on switching back and forth between radical and exponential form, okay? Because you got to have that down, okay? Because you see, obviously I've been around the block a couple times, but it's just the fact that exactly. I don't have to think about if 2 is the denominator that goes outside the radical, the 5 goes inside, right? It's just automatic, right? Because I've got it down. But you can also get it down, right? So it's not. This is not impossible things, okay? So again, for a summary, sometimes we can simplify, okay? Simplify before we start, okay? That will help us take the derivative, okay? Remember to move, if you have a expression, where you need to take the derivative, put that variable in the numerator, okay? So for example, right here, I had to put the x to the 1/2 in the numerator to take the power rule, okay? But when I'm getting ready to get done, okay, and again, I didn't, y prime. My apologies there. Okay, once you've taken the derivative, put that negative exponent back in the denominator, okay? And then rewrite your final answer as a radical, okay? All right, that's all I got for you guys. Have a wonderful day, wonderful weekend. God bless you. And I will, God willing, see you some of you on Monday.